Hi there and welcome to Vizlogic, where we discuss topics like data science, business intelligence, and data analytics. Data science is everywhere. It's changing how business operate, but what is it and how can it make an impact? Whether you're just getting started or looking to sharpen your skills, this series is for you. We'll explore what data science is, how to think like a data scientist, and the key roles that make it happen. Plus, I'll walk you through real-world case studies, like how PayPal combats fraud and how John Deere uses predictive maintenance to show you the practical impact of data science. By the end, you'll not only understand data science, but you also understand how to apply it in meaningful ways. Let's dive in. So, what exactly is data science? Think of it as a process of turning raw, messy data into actionable insights. It's smart science, hard problem solving, and it uses tools like statistics, machine learning, and domain expertise to make better decisions. Here's a great example: PayPal's approach to fraud detection. PayPal processes millions of transactions daily, making it a target for fraudulent activities. To protect its users, PayPal employs data science techniques that analyzes transaction patterns in real time by examining factors like transaction amount, user location, and purchasing behavior. They can identify anomalies that may indicate fraud. For instance, if a user who typically makes small purchases suddenly attempts a large transaction from a different country, PayPal systems flags this as suspicious. Machine learning models assess the risk and can halt the transactions for further review, preventing potential fraud. This approach not only safeguards users, but also enhances trust in PayPal's platform. That's data science in action, using data to make informed decisions and solve real-world problems. Now, what is data analytic thinking? It's the core to data science. It's about looking at data and asking, what patterns exist here? How can I use them to solve problems? Let's look at Amazon. They wanted to enhance the shopping experience by recommending products that consumers might be interested in, but hadn't considered yet. By analyzing consumer behavior, such as browsing history, past purchases, and items in the shopping cart, Amazon developed a recommendation system. This system uses collaborative filtering, which identifies patterns among users with similar interests. For example, if you bought a camera, the system might suggest accessories like lenses or tripods that other camera buyers purchased. This personalized approach increased the likelihood of additional sales and improve customer satisfaction. It's not about guessing, it's about leveraging data patterns to provide value. That's the power of data analytical thinking. Alright, so now let's talk about data-driven decision making, or DDD. Data-driven decision making is about using facts and data, not guesswork, to guide your decisions. It's a game changer in today's business world. Take, for instance, the company called John Deere, for example. They manufacture agricultural equipment and wanted to minimize downtime for their customers. Unexpected equipment failures can be costly for farmers. John Deere equipped their machinery with sensors that collect data on various parameters like engine temperature, oil pressure, vibration levels, etc. By analyzing this data in real time, they can predict when a component is likely to fail, a practice known as predictive maintenance. For instance, if the data shows a tractor's engine temperature is consistently higher than normal, it might indicate an impending failure. John Deere can alert the owner to perform maintenance before a breakdown occurs, saving time and money. This approach ensures equipment reliability and enhances customers' trust. The power of making decisions is grounded in data. Alright, now that we have a better understanding of what data-driven decision making and data science is, we can talk more of the roles in data science. Let's break down the key players in a data team. There is the data scientist, the data engineer, and the data analyst. A data engineer is like a construction worker. They build the pipelines and infrastructure that make data accessible and usable. Think of them as the people making sure the roads are smooth and ready for traffic. The data scientist is the problem solver. They analyze the data, create algorithms, build models to answer big questions. Imagine them as the architect designing the solutions. And finally, the data analyst is the storyteller. They take the results from the scientists and translate them into insights that the business can act on. They're like guides who explain what data means. Each role is critical, and while they overlap, they bring each a unique set of skills to the table. All right, now that we have a good understanding of the roles in data science, we can talk about frameworks. And for this purpose, since we are doing an introduction, we're just going to concentrate on one of the most popular frameworks, which is CRISP-DM, which stands for Cross-Industry Standard Process for Data Mining. Here's how it works. First step is business understanding. Basically, what problem are you trying to solve, or what problem are you solving? Data understanding. What type of data do you have? Is it enough? Do you need more data, etc.? Data preparation. Clean and organize your data. This often takes most of the time. Basically, you're going to need to organize it, extract it using different tools from different databases or even Excel, etc. Modeling. So specifically, if you are working with machine learning, you're going to need to build models. Evaluation, basically ensuring that the model is working and if it's describing and solving the specific problem that we are trying to solve for. And deployment. Deployment is where we put everything into action. It could be either a dashboard or for an automated system. For example, a healthcare provider might follow these steps to predict patients' no-shows. By understanding the business need, reducing missed appointments, analyzing patient data, appointment history, demographics, preparing the data, building a predictive model, evaluating its accuracy, and deploying it to send reminders to at-risk patients. They can improve attendance rates. Now that we have gone into details on one of the frameworks, we can also discuss a common pitfall when working in data science. And this is a concept known as overfitting. It's basically when your model performs great on your training data but fails when faced with new data. Think of it like this. Imagine you're studying for a test by memorizing practice questions. On the test day, the questions are different and you're stuck. Basically, that's what overfitting looks like. So what's the solution for this? You can use techniques like cross-validation, where you test your model on different parts of the data to make sure it works. Now, to continue going down the rabbit hole, data isn't just an operational tool. It's a strategic weapon for businesses. Take Netflix, for example. With millions of users streaming content daily, they've turned data into a core partner of their strategy. By analyzing viewers' habits, such as what you watch, pause, rewind, they have built recommendation systems that keeps users engaged. YouTube does do something similar, as well as TikTok and Instagram. But Netflix didn't stop there. When creating original content like House of Cards, they used data to guide production decisions. Some of the analysis were done in Netflix that showed that viewers like political dramas. By aligning these insights, Netflix created a series that almost guaranteed to succeed, and it did. Like, for instance, House of Cards, Squid Games, etc. So what is the lesson here? And it's simple. Treat data as an investment, not just an afterthought. The business that thrive are the ones that use data strategically to innovate and stay ahead of the competition. So going over these details, we can have a better understanding of why data science matters. It's not just algorithms or tools. It's about solving real problems. Whether it's a hospital predicting patients' needs, a factory preventing equipment breakdowns, or an e-commerce site personalizing recommendations. Data science empowers business to work smarter, faster, and more efficiently. And the best part, these skills aren't limited to massive corporations. Even small businesses and individuals can use data science to make better decisions and gain an edge. And in this channel, we will dive into further details on how to maximize the utilization of these tools in order to gain that advantage. Remember, data isn't just numbers. It's the story of the world. And as a data professional, you're the storyteller. Thank you for watching my video. If you have found this video valuable, give it a like or share with someone who loves this type of topics. Now, you can also comment what was your favorite case studies, or if you want me to go into details in one of the specific case studies that we discussed today. Now, until next time, if you have any other questions, comments, or concerns, you can definitely leave it at the bottom below.